So here we are, we're standing in front of a dirt wall. It's pretty pedestrian. It's the same as most walls that you've seen. We've got a variety of different kinds of construction here. We've got solid wall, we've got a couple of stacked walls, we've got a glass wall here. This is the same as basically every other wall that we've ever built. All standard components, standard behaviors. It does have one slightly different attribute, and it's really around its ability to move. This is a leaf elevation. So we've taken standard components, all these modules, and we've given them the ability to move and adapt and change rapidly. We have these vertical components, which are hinges. We have a track system that's part of the wall module itself and into the ceiling, and that's what allows all these components to slide back and forth in the assembly. In this case, it's going into a closet. It can just as easily mount into a straight line wall or into conventional construction. We can have two of these actually meet in a corner to define a small room and a space. But everything else within that is a completely standard kind of an entity. So you see as it's unfolding, it's coming out upon this track, and it's essentially just articulating across the top. And you can see that as it's folding and unfolding, it's doing this as a series of parallelograms. And very little effort. You can see that I'm just moving this with a couple of fingers, and then it will finally dock and be held straight. And in this case, in this configuration here, we dock into a receiver, and I have a pin that I will be throwing at the far end like this, and it is now locked into place. And that's as complex as it is. It's a really straightforward extension of everything that we've done. Not only can it be about a new elevation, which is what this is, but it's also completely retrofittable. Everything that we've ever built is capable of becoming part of a leaf elevation.